You all can touch your mobile, earphones and charger, but can you touch the WhatsApp? You can touch and you can use it, but are you really able to touch its software content? No, right? We have a control unit. This control unit will going to controls and coordinates all the flow of the information from one device to another device. In order to control all these operations, or in order to improve the speed of all these operations, then we require a unit. Then we are calling that unit as what? ALU. Hello everybody, a warm welcome to one and all. Welcome back to the session 2 of BCA's first semester, Unit 1 of a subject Fundamentals of Computer. In short, it is FOC. I am Rohini TS, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence, MYSURU. So before getting into our today's session, we'll just have a quick recap of our previous session. In the previous session of this unit, we had a discussion regarding definition of this computer. Computer is an automatic electronic machine that can process, store and recall the data. And also I have discussed regarding what are the characteristics of computers. So in order to remember that, I had given a code like SMS, AVA, CD. Fine. So this you have to follow. Speed, memory, storage, accuracy, versatility, automation, cost effectiveness and diligence. These are the characteristics, and also we discussed regarding what is data and what is information, and also we got to know regarding this hardware and software along with the history and evolution of computer. So in our today's session, we'll continue with this hardware and software difference, and at last let me discuss what are the functional components we have in a computer and how each component or unit will going to work out. That what I will be discussing in my today's session. Let me get into the difference between hardware and software. Already you know the definition of hardware and software. Fine. So what do you mean by hardware then? The physical components of a computer is called as what? Hardware, which is physical in nature, developed or manufactured with the help of certain materials here. That is what physical components of a computers are called hardware. Then what about software? It is made up of, or the software is a set of programs or a set of instructions, we can say. If it is a set of instruction, then that is program. If it is a set of program, then that is considered as what? Software. So physical component is hardware and the set of programs are called software. Then can we touch and feel this hardware? Yes. That is what? Hardware can be touched, see and we can feel it. So then what about software? Can we see it? No. So that is all what set of program it is. This is not physically existed. It is of virtual things. So that's why the software cannot be touched and we cannot feel this also. Let me give an example here, the difference between hardware and software. So here you all can touch your mobile, earphones and charger, but can you touch the WhatsApp? You can touch and you can use it, but are you really able to touch its software content? No, right? We can't feel, see and we can't touch it. That's why it's considered as what? Software in nature. And then what is the another difference? It can be constructed using physical materials or components. In order to have this hardware, we are going to use certain physical materials and components. Then how this software will going to be built? That too with the help of programming language. So here we are using certain programming language in order to consider or in order to manufacture or to develop any of a software. Then here it will not going to be affected by computer viruses. So virus is what? Software. That's why this hardware will not going to be affected by the virus, and this virus will going to affect the software. That's why the software is affected by the computer viruses, which are of a malware function which is not necessary for the computer. Then we are calling it as a virus. Then that will not going to be, this hardware will not going to be affected by the virus, but software is more prone to attacked by these viruses. Then here user cannot make copies. That means they can manufacture one more thing, but they cannot copy. So we can't have a replica of a existing hardware component here. But if you consider the software, we can copy, paste, we can cut and paste, we can replicate this copies with the help of some photocopy methodology. So here user can make the copies, but that is not in the case of hardware. Then what are the examples we have for this hardware? You can have a plenty number of examples for this hardware components of a computer. It may include monitor, keyboard, RAM, mouse, scanner, printer. All those are of what? Physical component that we can feel and touch. That's why it's considered as hardware. Then what are the examples we have for this software? You can consider OS, that is operating system, text editor, NUDI. So all these are the different applications or a software which comes under the example of this software. Okay. So these are the differences we can have for the hardware and software components. And also when it comes to the hardware, we can have all these monitor, keyboard and RAM and all. So if you consider the software, we have two types. One is system software and another one is application software. You can also write that point here. So that's all regarding difference. Next we'll move to the very important topic, that is all regarding functional components of a computer. Then how this computer will going to work, what are its functionality, what are the different units we have, what each unit will going to do, we'll see now. So in this, basically if you consider any kinds of computer, then it has to carry out the following function. If I wanted to consider any of the thing as a computer, then it must follow certain rules here. What is that? First, it has to accept the data and program as input. It must be able to take the input. That input can be what? Data or program. That is a set of instructions, or it can be a unprocessed data or raw facts. That will going to be considered as what? Input. After that, after taking that as an input, then it must store the data, programs and retrieve. That means it has to fetch it back when it is required. So as when and when it requires, at the time it must allow us to store and retrieve as well. So after that, what it has to do? It has to process the data as per the instruction which is given by the program and convert it into useful information. The main agenda is what? We are converting the data into information. Data are raw facts. When we have a processed data, then it can be considered as information. So in order to do that, it has to accept the input that needs to be stored, and it should allow us to retrieve when and where it is required. After that, it has to process that data. So fine. So based on the instruction, it has to process, then to the data should be converted into information. Then communicate the information as an output. So here, after the processing, it has to produce the resultant as the output. Okay. So these are the different functionality which will going to be done by the computer. Then based on all these functionality of a computer, then we are going to differentiate or categorize the hardware component into four main units here. One is input unit, processing unit, output unit and memory unit. Fine. What and all we have? Input unit, processing, memory and then output unit. We'll see each unit one by one along with the functional components of a computer diagram. Fine. Here you can see that here we have a representation of a functional components of a computer. As I told in the previous slide, we have a 4 units. One is input, output, processing and we have a memory unit. So here clearly you can see that first I am giving an input here as a data, but I am expecting an output as a information. That is what resultant. First here you can see that we are feeding a data as an input by making use of a input unit. So this input unit will going to be a collection of one or more input devices. You must know the difference between unit and devices. If it is a collection of devices, then I can consider that as a unit. So here we had written input unit. So it will be a collection of one or more input devices. It will be a collection of one or more input devices. So with the help of keyboard, mouse or a scanner, we can give the input. Fine. So after taking the input, what it will going to do? It will send that into the storage space. That is what comes under the memory. So in the memory we have two types. One is main memory and secondary memory. If you wish to store your data temporarily, then we have to go with this main memory, and if you want to store the data and information permanently, then we must use this secondary memory. After taking a data and programs as an input, that comes and will be stored in the main memory, which is required for the processing. That data and information will be stored in the main memory. So we are calling that as a RAM or random access memory. Fine. So with the help of this, with the bidirectional data will going to be exchanged between the memory input as well as CPU. So that is what central processing unit. Again we have three components within the CPU, that includes ALU, control unit and register. So when it comes to the ALU, that is the abbreviation of arithmetic and logical unit. So whenever we are using a computer, there we may have a arithmetic operation, logical operation, all those kind of operations or computations will going to be done under this ALU component, and we have a control unit. This control unit will going to controls and coordinates all the flow of the information from one device to another device. Then we have a register. After taking an input and before processing that and before storing that and before giving it as an output, the content will going to be stored temporarily in the register. That will just going to act as a buffer. It will going to store the data and information which is necessary for the purpose of processing. That will be stored in the register, and here we have a memory unit, primary memory and secondary memory. It will be volatile in nature. If we turn off the computer or if power goes off, whatever the content we have in this main memory, everything will going to get vanished, or it will just going to flush off all the data. But that is not in the case of secondary memory. Why? Because in the secondary memory, it will going to store the data permanently. That is non-volatile in nature. Okay, that is what it is able to store the large amount of data than this main memory. So now input is taken, processing is done. Now it's stored in memory. Now this should be processed, or this should be given to the user as a resultant, that too by making use of this output unit. So it will be also a collection of one or more output devices. So you can take the example of a monitor, projector, printer, all those are examples of this output unit. So with the help of that output devices, we can give the resultant as the information. Okay, whatever the data that we are giving should be understood by the computer, then it can be able to process. After the processing, it should produce the resultant which can be understood by the user or the person one who is seeking the resultant from the computer. So with the functional components, we had taken a data as an input and we are getting a information as a output. This is how the functional components of a computer will going to work. So here you can see each one of the components here. First we have an input device. Mainly this input device is a hardware. Already you know what is hardware. It's a physical component, fine. Then it will allows us to enter the data and instruction into a computer. It is allowing us to give the instructions or data which is required as an input that we are giving with the help of this input device. Then what are the examples which comes under this? We have a keyboard, mouse, scanner. Okay, all these are the example. Here you can see the images of this input devices. Mainly this will going to connect the external world. It will connect the external world to the computer, right? Why? Because this input device, with the help of this input device, we are giving a data and instruction as an input to the computer. That is why it is building a connection between the external world to the computer. But when it comes to the output, that is building a relationship from the computer to external world. Okay. We'll see the next component, that is what CPU, in short it is central processing unit. CPU is the part of computer that carries out the instructions of a computer program. Whatever the instructions or set of programs we have, everything will going to be carried and controlled by this CPU. Mainly it is a unit that reads and executes a program instruction. So where the reading and execution of a program instruction will going to take place? that is in the component of CPU. That's why we are calling it as a brain of the computer. Without the CPU or a processing unit, we wouldn't be able to do anything. That's why the CPU or central processing unit is considered as a brain of a computer. Here, the main function of the CPU is to interpret the instruction in the program and executes them one by one. So, it will going to take all the instruction or set of program or data as an input, then it will going to process everything one by one. So here, based on this, it will going to be of three major units we have in it. One is ALU, that is arithmetic and logical unit, control unit, and registers. So what about the work of this control unit? Mainly, this controls and directs the transfer of program instructions and data between the various units. So here you had seen this dotted lines. This control unit will going to control and coordinate all the exchange of data or flowing of data from one device to another device. That will going to be controlled and coordinated by this control unit. In short, we are calling it as what? CU. That is control unit. Next, what we have in it, the main activity is to maintain the order and direct the operations of the entire system. It will going to controls and coordinates all the functionality. Along with that, it will just going to make a sequence which work has to be done based on the priority. Everything will going to be managed and maintained by this CU or control unit. Fine. Then what is the second component in the CPU? That is register. Why it is required then? It is used to store the instructions and it is helpful in order to store the intermediate data which may be generated during the processing. When we are doing a processing, for example, if my input is 2 plus 3, here plus is what? Operation, right? And 2 and 3 are my input. So, this will going to be collected with the help of some input devices. After taking it, before processing or before doing the addition, this needs to be stored somewhere else. We can't keep this input whatever we had taken from the user where and all we require. So that needs to be stored or that should be stored in a proper manner. So for that reason we have this register which is required for the processing or which has a intermediate data which is under the processing or which needs to be given as a resultant. All kind of that data will going to be stored in this register. Mainly it is used to store the instruction and intermediate data which is generated during the processing, that will going to be stored in the register or buffers. Next, what we have one more component, mainly important, arithmetic and logical unit. As the name indicates here, arithmetic and logical. Already you know about arithmetic operators, right? So what is that? In order to perform the addition, subtraction, multiplication, division and modulus, those are all arithmetic operation. And then if you consider this logical operation, that includes and, or, and not. So when it comes to the arithmetic operation, in this we have addition, subtraction, multiplication and division. So if my input is based on any of these arithmetic operation, then that will comes under this ALU management. Then if my input is, or if I am searching or doing the programming with respect to the logical operation, even that is also comes under this ALU only. So and, or, and not are the operations which comes under this logical operation. So in this and, if both the condition 1 and condition 2 both are true, then it will be true. So in this logical or, this is pipeline in nature. So if any one of the condition is true, the resultant will be true. And what about not? If my input is 1, the output will be 0. If my input is 0, output will be 1. It is just acts as a what? Inverter. Okay. So in order to do all these kind of operation, we require this ALU or arithmetic and logical unit. And also we have certain relational operations to make a comparison, like lesser than, greater than, lesser than or equal to, greater than or equal to, is equal to, and we have a not equal to. In order to perform all these operations as a functionality, we require this ALU or arithmetic and logical unit. So in order to control all these operations or in order to improve the speed of all these operations, then we require a unit. Then we are calling that unit as what? ALU. Fine. This all regarding what the different major components of this CPU. So we got to know regarding input and CPU. Then what we are left out with? We have a storage unit. So why we require human brain? In order to memorize. In the same way, if you are taking an input and if you are processing it and producing as a result, that should be stored somewhere else in a computer system. So that's why we have the storage unit. If you want to store the data temporarily or which is smaller in size, then you can go with the main memory. But if you want to store the large amount of data or if you want to store the huge information, then we have to go with this storage unit. That is what? Secondary storage. So it can hold more storage data than the main memory and it is less expensive. RAM is more expensive, that is what primary memory, which is inbuilt memory. But this storage unit or a secondary storage devices are not so expensive when it compares to the primary memory. And also it has considered as what? Additional memory, and also we can call this as a auxiliary memory. We can consider this as auxiliary memory and it is able to store the data and information permanently. It is non-volatile in nature. And what are the examples comes under this secondary storage device? It includes floppy disk, magnetic disk, hard disk drive, compact disk, that is CD, and we have a DVD, that is what? Digital versatile disk. So these are the different devices which comes under this storage unit, mainly used to store the large amount of data or huge information can be stored. It will be more efficient and effective in nature in order to store the large amount of data, and it is not so expensive. You can consider it as what? Inexpensive. It's all regarding the storage unit. We'll see the last component. That's all regarding what? Output unit. It is just a reverse of input unit. Input unit is, or input device is taking the input from the user. This output unit will going to produce the result and it is giving it as a information or resultant to the user. Right? An output device is any hardware component that conveys the information to one or more people in user understandable form. As I told earlier, whenever we are giving an input, that must be understood by the computer, then only it can process. But if I am getting the resultant in the terms of zeros and ones, that can't be understandable. That's why whatever the output that we are getting, that should be in the understandable form to the user. So that is work is done by this output unit. If you consider the input unit that conveys or that will going to build a relationship from external world to the computer, this output unit will going to build a relationship or it will going to links the computer to the outside world. Okay, that is what the major difference. And also mainly we are going to use this output unit in order to print or to display the resultant which are stored in the memory unit. That is why there is a virtual line or virtual connection between all the devices, input, CPU, storage as well as output devices. Every component or functional component of a computer system has a connection between all those things. So here mainly the output unit will going to link the computer to the external world or to the outer world. Then the monitor and printer is considered as the most commonly used output devices. Along with that, we can also have speaker, projector. All these are the examples which comes under the category of this output devices. So I hope you all understood regarding the functional components of a computer system that comprises of input device, and we have a processing device or a processing unit, memory unit, and we have a output unit. So by comprising all these things, we can see the functionality of a computers in order to satisfy the requirements of a user in the effective and efficient manner. Let me meet you in the next session with the classification of computer, which will be based on the principles of its operation along with based on the configuration, size and performance. Based on that, we have certain types of computers here. That is what I will be discussing in my coming session. Let me meet you in the next session. Until that, keep learning, keep on growing. Thank you.